Welcome back to Physics 30. This is the second part of the laws of attraction virtual experiment that you did. So hopefully you labeled this and you went through it. You did the preamble manipulations here, the experimentation. And then you looked at the two things. So varying mass while keeping the distance the same. And then finding out what you think the relationship is there, and then keeping the masses constant and varying the distance and getting your results there. And hopefully, at the end here, you were able to, I guess I need to plug in my little notepad here. So hopefully at the end, you were able to actually find a relationship between force and all those variables, and then come up with a combined relationship here. So force is directly related to what in terms of the two masses and the distance, and then over here simply saying force is directly related to, and hopefully you can answer that. Now that leaves part two here, the post-lab. So you'll for these, we can imagine that, okay, we'll get a certain force, and our force is related to M1, M2, and the D. I think I called it D for distance, in some fashion, right? Now I can't really go into that because I don't want to ruin the previous page. So you can think of, when I have a mass of 1, and a distance of 1, that's going to give us a force value of, I'll just call it 1 for now. So it's some value, okay? And then for the rest of these, you have to take a look at, okay, now what's going on over here? So with part 2 here, this mass is 1, but mass 2, so we could say mass 1 has become, it's become just simply, let's have it, because we're looking at factors here. These are force factors. So M1, we could say, okay, it's becoming 1 times bigger, because it's just simply the same thing. M2, it is becoming, let's see, 36 times bigger. And the distance here has become 6 times bigger. So whatever you have here for forces directly related to something, you'll make M1 just a value of 1, M2 a value of 36, D a value of 6. Then that'll give you how much greater the force is. Now here's the kicker. With this particular question, you want to, each of the 4 diagrams shows the configuration of gravitational attraction is the same. So we have to look at what's happening here in terms of what I need to do to make it be the same. So that kind of gives you a hint in terms of what your previous answer on the previous page should be, because when I double this mass, or sorry, when I take 36 times this mass and 6 times the distance, it should also give me a force value of 1. Okay? So that when you get to example 3 and 4, we know that we need to get a force value of 1 times the size. Because really what we're doing is we're taking force over F naught, and we need to get a 1 here divided by 1 to give us 1, indicating that it's 1 times the size. So you have to figure out what mass here would work, such that when I do the manipulation, I get a value of 1. So when I take my new force divided by the old force, I get 1. And of course, what must this mass be? When I triple this mass, the distance is 6 times greater than this. And over here, doing the same thing, except you're making up all the values, such that when I put these factors into this force proportion here, I should get a value of 1 overall. All right? It's kind of difficult for me to explain this without giving you the proportion, so I'm kind of skirting around the issue of what the proportion actually is. All right? And then using that idea, using the same thing, looking at this. So if the gravitational attraction between 2 masses, 2 meters apart, is 1 times 10 to the minus 8 newtons, what is the attraction between them if we are changing the distance? So we're told nothing about masses, so we assume the masses are staying the same. So it goes back to looking, okay, how does force compare to distance? And again, I can't tell you what it is because that's what the point of the lab is. But what I can do is say that they was originally at 2 meters apart. So if I'm going to 4 meters apart, that's times 2. So you'll be entering a 2 in for the D. Okay, to see how that, now over here you'll say how many times bigger or smaller the force is, and then apply that to the old force. Old force multiplied by factor gives, new force. There we go. All right. And then over here, 1 meter apart. So when I'm going from 2 meters apart to 1 meter apart, of course, that's times a half. So for the distance, it's going to be half times greater. So over here, you'll write down the force factor, and then, of course, figure out the new force by taking the old force multiplied by that factor to get the new force. All right? So that's how you handle this last page. And of course, if you still have an issue with how you tackle this, definitely ask me and I can hopefully help you out with that. But that should give you enough information to finish and hand in that lab. And again, if you have questions, don't hesitate to ask. All right, we'll see you again.